All right, so we're looking at completing this square, right, which is a really cool way of solving these quadratics for values of x here. What's great about this algorithm is it works every time, whereas something like factoring is usually easier and favorable, but it only works some of the time. Completing the square works every single time. We got two examples here, and we're going to go through this step-by-step procedure to solve for x. All right, so let's get started. Let me take so we can focus on one at a time. Let's move this set over, and the equation's in the graph. Okay, perfect. What I have here is the procedure of completing the square, which we'll just take down a little bit at a time and focus on step by step. Okay, the first step is, are you in standard form? Right, so we identify what's A, what's B, and what's C. Right, so you can see our quadratic is set equal to 0. Right, A is going to be the number in front of x squared. Right? B is going to be the number in front of x, and then C is going to be the constant. Okay. So when I say A in this example, I'm talking about 1. When I say B, I'm talking about 12, not 12x. I see that a lot. Okay, let's not do that. A, B, and C are just numbers here, and C is 20. Perfect. All right, so step 1 is done. Okay. Step 2, divide everything by A. A is the leading coefficient, right? And sometimes this is 1, like it is here, which is great because this step really, divide by 1 does nothing, right? So it's kind of already done for us. But in any event, you want the number in front of x squared to be 1 before you complete the square. So that's done for us. But it's not always done for us, okay? Move C to the other side. So from our equation here, we know C is 20. So I'm going to subtract 20 from both sides. All right, and what does that do? X squared plus 12x equals negative 20. Nice. Okay, so that's done. Next step, and this is where the magic really happens for completing this square. This is what makes it a square, right? Take half of b. So whatever number is in front of x, I'm going to cut that in half. I'm going to square it, right? Or multiply it to itself, or give it an exponent of 2. These are all the same thing. I'm going to add that to both sides. Well, if b is 12, and it is, half of that is 6. 6 squared is 36. So we're going to add 36 to both sides of our equation, right? Not 36x, just 36. So x squared plus 12x plus 36 equals, and then negative 20 plus 36 gives us a positive 16. Okay, so step 4 is done. Okay, and go ahead and get rid of that. Factor and solve for x. Okay, so now this will definitely factor, and it'll factor into two identical binomials, right? Given, and you'll see the square come into play. Okay, so ignore the 16 for now. Look over at the left. I need two numbers that must multiply to 36, and they must add to 12, right? So if it helps, you can write out the factors of 36. Right, 36 and 1, sure, but they don't add to 12, right? 3 and 12, but they don't add to 12. 9 and 4 don't add to 12, but 6 and 6 do, right? So let's draw our double bubble. This will factor x plus 6 times the quantity of x plus 6. And don't forget that is equal to 16. All right, let's bring our graph with us. I want to show you that the solutions are already here. Right, you can see on the graph what the value of x is going to be, negative 10 and 2, but I think the illustration helps a lot. So let's put this bad boy over here. Okay, cool. All right. So looking over here at the left, something times itself is just that something squared, right? Oops, forgot to turn. There we go. So if I say it's squared, that just means it has an exponent of 2, right? Equals 16. There we go. Okay, so now we can solve for x in 2 steps here, right? To get rid of this 2, I'm going to take the square root of both sides. So I'm taking the square root of both sides. X plus 6 equals the square root of 16. All right, what number times itself equals 16? Okay, so we got rid of that. All right, now 16 is a perfect square, so this problem works out pretty nice. Right, but remember, when you take the square root of something other than 0, you're going to have 2 answers, because both positive 4 and negative 4 are the answer here for the square root of 16. So let's go ahead and write that. X plus 6 equals both. And as a shorthand, let's write a plus sign and a minus sign on top of it. That just means both a positive 4 and a negative 4. Cool. Come here, graph. Okay. All right. Now to solve for x, we are going to subtract 6 from both sides. All right. And we really got to do this twice. Okay. When I subtract 6, I won't do, there we go. Okay, perfect. Minus 6 minus 6. Okay. When x is negative 4 and I subtract 6, that's negative 10, right? Okay. So x equals negative 10. And when x is positive 4, or sorry, when x plus 6 is positive 4, all right, positive 4 minus 6 gives us negative 2. Because remember, when we're solving for these quadratics, what we're really doing is finding the x-intercepts where y equals 0, right? You can see here the graph with all the important parts, all the important points here, right? And the two specifically I want you to look at is the x-intercepts. All right, what's the value of x when y equals 0? Both negative 2 and negative 10 are correct. So boom. And we'll circle our final answer. Nice. All right. Step up the difficulty a little bit. Where's that other bad boy at? Okay, we'll take him and move him over here so we can reference our procedures, the completing the square procedures. Okay. And we'll bring our graph with us. There's a good spot for him. So we already know what our answer should be, right? When y is 0, x is negative 5 and negative 1. Let's complete the square and see what happens. Okay, step 1, sit in standard form, identify A, B, and C. Yes, it's in standard form, right? It's set equal to 0. We know that A equals the number in front of n in this case, right? I know it's usually x, but it's just a variable. Don't think too much about that, right? This could easily be x instead of n, right? B is the number in front of n. Okay, and C is the constant. Whoopsies. Perfect. Okay, cool. Okay, so we do need the leading coefficient, all right, to be 1, positive 1, to be more accurate. So I'm going to divide everything by 2. Let's go back to our original. Let's divide everything by A. All right. All of these terms, and technically even the 0 gets divided by 2 as well. All right. Remember, you can have 0 on top of a fraction, but never on the bottom. Okay. These two cancel. That's the whole idea. All right. So n squared. Okay. And then 12 divided by 2. 6n. And then 10 divided by 2 is 5. All right, equals 0. 0 divided by 2 is 0. Right. And I guess I should clarify here that when I say take half of b, right, this is going to change and make 6. We're going to take half of 6, right? Then whatever term is here in the middle, all right, x or n to the first power, that coefficient, that's what we're going to cut in half. That's what we're going to square and add to both sides. So we're going to cut 6 in half, all right? And we're going to square that 3, and we're going to add 9 to both sides. Right. Oh, after we move 5 over. After we move 5 over. So n squared plus 6n plus 9, right? Remember we cut 6 in half and squared it. Okay, and then negative 5 plus 9 will give us 4. Bring our graph with us. All right, so I really want to build the connection that the answers we're getting are just the x-intercepts. All right, cool. All right. Now this on the left will factor quite nice too. You'll see that, a square or an exponent of 2, two numbers that will multiply to 9 and add to 6. Notice when we cut 6 in half, we got 3. All right, and this will factor to be n plus 3. That's not a coincidence. All right. Whenever we cut this middle term here in half, before we squared it, right, whatever that was, that's what this is actually going to factor out to be every time. So n plus 3 times the quantity of n plus 3 equals 4. Two binomials that are identical, something times itself. There's just that something squared. So the quantity of n plus 3 squared. If you ever hear me say the quantity of, right, that's what we're talking about, these parentheses here, right? You wouldn't say parentheses, n plus 3, 2, right? We say the quantity of. Okay, now 2 steps to solve for n here, right? Just like in the last problem. Get rid of that 2 by taking the square root of both sides. So n plus 3 equals the square root of 4. Right? Yeah. And what number times itself equals 4? Well, that has two answers, both positive 2 and negative 2. All right, so n plus 3 equals positive and negative 2. And when I subtract 3 from both sides, right, run through this twice. All right, positive 2, or let's go with negative 2. Negative 2 first, not that it matters. Negative 2 minus 3 and equals negative 5. Don't forget our little buddy here. Come on, little buddy. Okay. All right. Negative 2 minus 3 is negative 5. And positive 2 minus 3 is negative 1. Both answers are correct. Now let's look over here at our graph. What are the x-intercepts? When y equals 0, we have negative 5 and negative 1. And let's circle that final answer. All right. Keep it short and sweet. Hopefully that helps a lot. And all right. Appreciate you. Bye.